Alright guys, so we're going to start going over the Arduino code for the tank driving mode on our remote control car. To start out, we're going to have to include some libraries. The wire.h library allows you to communicate with I2C devices. The software serial library, we've used that before, you know that allows us to establish serial connections. And the last three all have to do with the IMU. Those are specific to Adafruit and that product. So you're just going to have to include those. Next off, we're going to declare our RX and TX pins, declare our serial connection down here called XB. Also, we're going to declare a variable of type double called maxDisp. And the reason we're doing that is because we don't want to have to rotate our controller a full 90 degrees in order to get forward or backward movement. So you'll see later on in the code, all this is doing is saying, instead of 90 degrees corresponding to 100% speed, instead it's going to be 60. You can set that to whatever you want. It's just going to change the sensitivity of our remote. Next off, you have to include this line. This is another mandatory line for this Adafruit product. This essentially creates an object called BNO, and that's going to reference the IMU later on in the code. Next off, we have our setup function. This is going to run once. You're going to start out your XB communication at this baud rate of 9600. And this if statement is basically saying if you're not able to begin communication with the IMU, then we're just going to go into an infinite while loop, which will basically stop our program. We will wait 1 full second after that to make sure that we have communication. And then we will go into our main loop. So to start out our main loop, we will get a new sensor event. As you can see, we're referencing the object called a BNO that we set up top. Once we have that object, we can start referencing our orientation data from the IMU. So as you can see, we declared Y displacement, a Z displacement, and an X displacement. And all you have to do in order to reference those variables is say event.orientation. And then the axis that you're interested in. And we initialize these variables at the top of our code. You can see we initialize them as doubles and set them equal to 0. It really doesn't matter what you set them equal to up top because they're going to change every single time your code runs through an iteration. Next up, we want to make sure that our displacement that is recorded by the IMU is not greater than the maximum displacement that we set at the top of the code. So we use a combination of max and min functions in order to take the maximum or the minimum, depending on if we have a positive or negative displacement, just to make sure we're within that certain threshold in between the negative maximum displacement and the positive maximum displacement. Next up, this is the section of the code that actually determines which way our IMU is turning. The way this code works is we're basically finding out which axis has the most dominant deflection. As you can see, this if statement is saying if the absolute value of our Y displacement is bigger than the absolute value of our Z displacement, that means that we're essentially trying to turn left or right. If our Y displacement is greater than 0, then we want to turn left. Otherwise, we want to turn right. And left and right is basically symbolized by a single character, either an L or an R. And our velocity is going to be chosen by taking our displacement and dividing it by the maximum displacement that we designated above. It just happens to be 60 right now. And then times 400. And we're multiplying it by 400 because that's the maximum speed that can be set on our motor controller. And we're going to do the same thing for the Z displacement. If the Z happens to be bigger than the Y displacement, that means that we're trying to go forward or backward. So we're going to set the variable direction either to drive or backwards. Again, those are just single characters. We also set up the velocity the same way that we did up above. We are going to send this information to the XB using xb.print, and specifically we're going to be printing the direction, whether it's left, right, drive, or backwards, and then a comma, and then a velocity, which we calculated in this line and this line. And that is going to have an accuracy down to 2 decimal places beyond the period. Last but not least, we will print a new line, and this whole chunk of code represents 1 line of data that's going to be sent from the XB on our controller to the XB on the remote control car. So now let's go take a look at the code that's going to go on the car. Alright guys, we're going to start going over the code that's going to go on the remote control car itself. Again, this is for the tank driving mode. This time we only need to include two different libraries. The first one is for the motor controller that we're using. It's the dual MC33926 motor shield. The next one is the one that we've been using all along, the software serial.h. The next two lines we're going to again declare our RX and TX pins for the XB and then set that up using the software serial function. This chunk of code, these are all initializing variables that we're going to use later on in the code. One by one we'll see those and then refer back up here to where we initialize them. Here we're creating an object using this internal function. This is provided by the manufacturers of the motor controller. You will probably have to download a special library to use this. This is all you have to do to declare the object though, and now we have an object called MD, and that is for the motor controller. In our setup loop, we're going to begin our XB communication, again with the specified baud rate of 9600. We're also going to initialize our motor controller using md.init with brackets, and then that again refers to the object that we initialized in this line. Now as we go on to our main loop, this if statement is basically where we are going to read in our command from the XB. So to break it down further, if the XB is available, we're going to read in one character at a time from the XB using the command xb.read, and we'll assign that to a variable called command, which we initialized up top as a character. Now, if the character that we just read in was the character that represents the end line, then that means that we've reached the end of a full command received from the XB. So we are going to set a Boolean value called parse time equal to true, which we initialized up here. It was initially equal to false, which means we hadn't yet received a full command from the XB. But now that we have, it is now true. Now if that wasn't true, let's say we received a character halfway through the command, we hadn't yet received the end line character, then we're going to continue within this if statement and wait for the next character to come in. The rest of this loop only occurs if parse time is true, which means that we have received a full data set from the XB. Now if we have, we're going to search through that string that is stored inside of total, which is the total command. We're going to search through it to find the comma, and total.index of, and then with the character comma, that will store the index of the comma in that string, and that's stored in the variable called comma, and that's what we also initialized up top as an integer. We're going to find the part of the string that represents the direction that we want to travel, and that's basically going to be the part of the string from the very beginning to where the comma occurs. And then the velocity, same idea, it's the part of the string from the comma to the end of the string. We can also convert that velocity to a float because right now it's in the form of a string. Once we've done that, we can start specifying what direction we want the motors to spin. If the direction that we receive from the XB is a B, that means we can set the first motor to a speed of velocity, which is the variable that we read in as the second half of the total string. The reason that we're setting these velocities, one is positive and one is negative, is because in our specific setups, the motors are wired to our motor controller with opposing polarities, which means for the entire car to go forward, motor number 1 actually needs to spin forward and motor number 2 actually needs to go backwards. So you can see that there are different combinations of a positive velocity and a negative velocity depending on what we want the car to do. B is to go backwards, D is to go forwards, left, and right. So you can see left, the combination for left and the combination for right are opposite, which makes sense intuitively because we want both motors to go opposite directions. As you can see, each command where we actually set the motor speed is just MD, which is the object that we specified above, right here. And then so it's MD dot set M1 or M2 speed. And 1 and 2 just represents the ID for the specific motor. And then once we've done with that, we're going to reset the string that contains our last command received from the XB. And it's now an empty string. And we're going to reset parse time equal to false so that the next time we start looking in to see if there are more characters received from the XB, we're going to be starting from scratch. So next up, we're going to start looking over the code for the car driving mode.